Hello everybody, my name is Soheil and today I'm going to talk about OpenFlow switch specification. The document that I used for this presentation is version 1.5.1, which at the time of this recording is the latest one. Of course, you always can download the latest version from opennetworking.org. So a little overview of software-defined networking. As you probably know, the main purpose of the software-defined networking is to separate the control layer from the infrastructure layer or forwarding plane in the switch or in our routers. So we have two main parts. The first part is the northbound, which focuses on communication between application layer and the control layer, and the second part is called southbound, which focuses on communication between the control layer and infrastructure or our forwarding plane. So OpenFlow operates in the southbound of the software-defined networking architecture. About the switch component, the OpenFlow should have at least one flow table and one group table. So the flow table and group table, what they are doing is basically packet lookup and forwarding. We will also have some OpenFlow channels. So these channels are a way to communicate to the external controllers, and the controllers, of course, they can add, update or delete flow entries in our flow table, and they can do it either reactively or proactively. When we have a packet coming to our ingress port, matching starts at the first table, and it basically processes to the consecutive tables. And it's important to know that if we find a match in one of our flow entries, it has priority. So the first match has the priority over the other matches. So that's important to know. Then here we're going to talk about the OpenFlow ports. We have the first kind of the port is, of course, the physical port, which is basically the Ethernet interface. We have some logical ports that they are not linked to a hardware interface, and they're kind of like a higher level abstraction. An example could be our link aggregation groups, tunnels, or loopback interfaces. And the third type would be our reserve ports. Basically what they do is they are generic forwarding actions. They do the generic forwarding actions for the OpenFlow, and for example, they can send packets to the controller, or they can flood to all the ports of the switch, or they can just simply forward the packets using OpenFlow methods. We have ingress and output ports, of course, and they all can be grouped together. Each port have port counters for taking statistics about the output, ingress and output packet, and they all have state and configuration flag basically. So this is kind of like a picture for the processing pipeline. As you can see, the packet enters here, goes to table 0, and next going to the next table till it find the action which is appropriate for this packet, and based on that action we will send it to the output port. So again, here we have those steps. Packet processing starts at the flow table 0, and packet is matched against the flow entries of the flow table. And if we have a match, the instruction set in that flow entry will execute. We might have go to table instruction, which means that send the packet to another table. And we have to know that the pipeline processing can only go forward and not backward. So in this example, if the direction of our ingress packet is from left to right, so in this example we can only forward to the right, we can go only to the right, so we cannot go from table 1 back to table 0. We can only go to the right direction in this example. And we will have, of course, something which is called a table miss. So if we don't find any flow entry in our table, we should specify what will happen in this case. So we will probably specify that drop the packet, for example, if we don't find any flow entry in our flow table, or pass it to the controller, or pass it to another table. But if we don't have any table miss flow entry, the packet will be dropped. So here we have two types of OpenFlow switches. The first one is going to be the OpenFlow only, which means that all packets are processed by the OpenFlow pipeline. And the other one would be the hybrid model, which the OpenFlow operation and the normal Ethernet switching modules work parallel to each other. So in the hybrid model, if we want to move from the OpenFlow module to the traditional module, we have to use two reserved ports, which is the normal port and the float port. So the normal port is, as the name mentions, it's only used for the normal operation of the forwarding, and in the float port we basically send the packet to all ports of the switch except the one that it came in, except the basically the ingress port. Sorry. Here we're gonna talk about the flow table. So each flow table consists of flow entries, and these are the main component of the flow entries. We have match field, which are they are used against finding a match, and they can be either ingress port, packet header, or some metadata specified from the previous table. We have the priority, which basically gives which matches the priority of the flow entry, and we have counters, which will be updated when the packets are matched. We have the instruction, which is basically the action that to modify the action set or pipeline processing, and we have timeouts, maximum amount of time or ideal time before the flow is expired by switch, and we have the cookies, which are some opaque data values by controller, and they might use by controller to filter some flow entries affected by flow statistics. So this is not usually used at the time of the processing packets. This is something used more related to the gathering statistics and during the flow modification or flow deletion request. And of course, we have the flags that they can change based on the flow entries that they are managed, basically. So here again we have the matching processing. Basically, when the packet enters, it goes to our flow table. In the flow table we have several flow entries. So if we find a match, and if that match points to the output ports, we just apply the action, we modify the packet, we update the match field, we update the pipeline field, and we finally send it to the egress port. But if the action basically are meant to like if further processing is needed, we have a different set of actions. So we clear the actions, basically we empty the action list, we write the new actions, and we send it to the next table ID. We send it to the next table, and the next table, basically the same process applies to the packet, and finally either we drop the packet or we send it out to the egress interface. So that was a summary of the first 5 chapters of this document. I hope this has been informative for you, and I want to thank you for your attention. Thank you.